That's right. See, now it is stemmed here. Let her join. Okay, you can see hating is removed now. The words are pretty much taken care of. Okay, now this is the text. So if you do df text, right? So now after send it to
why you created the function underscore home that stay.
see here what it is doing. It is taking each list. I mean, after the word tokenizer is done, it is taking each list, stemming it up, joining it back here, right? So now your text data is very much stemmed out. Now we'll be passing this to count vectorizer. cv.fit df.text. Right? If you go cv.transform df.text, you can see 13, two lesser columns, right? And you have a lot of options now. cv is equal to count vectorizer stop words. So that E is the, lot of those words are there. That is, you can see number of words is reduced to 6 now. A lot of words are omitted.
Each are
Those words are gone. You can see now, right, how much lesser information.
if we revert back to the original fund, then that is it will come automatically.
Right. Okay. And nothing changes in the original data, but now the data is transformed. If you give two array, you see here. If you want to understand vocabulary, good is 0, hate is 1. Is all clear? E is the, all those words are gone completely.
will not come here. So after transforming the data, so you cannot return back.
So you have this API inverse transform. Okay, so Nilanjan, I think you got a little late to join. So what we did is, see here, we stemmed for each word, all stem for, we created a list, right? Then we joined it by created a sentence. Okay, so this was the function and we did for all the rows. Then we are doing stop words. Stop words is to remove all not so significant words, and when you do so, now the size of contents and the number of columns actually is reduced from 15 to 6, right, where this tells you the column information. Is it clear?
So can we see the newly formed sentence? Newly formed sentence.
Yeah, newly formed sentence. If you do df.text, you'll see. Hello, how are you? This is this. The root is thi. You can see hate and hating were there, right? Actually, right now your data becomes, both of them is converted to hate. Is it clear?
So in CV.vocabulary, only the changed words have come, not the ones.
Not the ones. Okay. So if I do CV dot inverse transform, so this.
Because if you see the first sentence, hello, how are you? We just see that R is there. Other.
Right, you can see only one word are here.
Yeah.
That's it.
Only the change one it shows.
Right. And the data is now shrinked, actually changed. Right. If I do this is a transform data, right? I can pass it as a argument to my int. What was the column? D. See here, the category is 2 column actually. Yeah. So the first line became hello. Next line became good hate run the good hate import run. Is it clear?
All each error removed. Each error or not removed.
Right. So the number of, this is the vector format now. You can see the vector is pretty small, right? It is 6 columns here now. That was the problem that you were mentioning, right? You have 1 lakh column. How do you do? These are the techniques using which you will shrink. One more technique. Okay. Sometimes, the words like not good, is it a positive word or a negative? This is different word, right? Not good. Okay, but you need to treat them with together, isn't it? Not good is a negative sentence, negative comment, but good and not individually are not negative. Understood? So you might have to use this technique of n-grams here. These are known as n-gram. See there. Now you are taking into consideration 2 words: import run, the good, isn't it? See, good run hate. You're taking both words at a time. This is n-grams. Okay, and this is situation because n-grams I have started with ranges 1 and 2. 1 word and 2 words. Both will be taken into account. Is it clear? Fine, right? Then the next option is TF-IDF. Okay, TF-IDF. Let's understand that. Is it so hot? Just now. I think power is not there. Let's continue. From sklearn, feature extraction. Feature extraction or text. Oh, sorry, I didn't write text here. Oh, here it is. TF, there are two things: TF-IDF transformer, TF-IDF vectorizer. Okay, so let's understand what is for first vectorizer. Right. So now, consider this case. Suppose you have a lot of documents. Okay, and there is a word which is more common in one document versus all the documents. Understood what I'm trying to say? Like in Wikipedia, there is a document which uses the word politics, Obama, Iran, Iraq, petrol, crude oil. What is this document about? I mentioned the word Obama also.
Politics.
Yeah, Wikipedia page. So I'm talking about Wikipedia, where there will be about special person, or this page is most likely about Obama, right? Yeah, I mean, if you consider other thing, petroleum and all that, there will not be Wikipedia pages for that. Petroleum and all that. I mean, it's petrol word will be very generic, it will be in millions of places. But Obama's name will be more, the density of the word will be more in that document compared to the entire collection of document. That is what is called corpus. Right? Okay, so if there is a word and which is occurring more often in a document compared to the entire corpus, that word is important in the document. That is TF-IDF vectorizer. So here in this technique, you will find out what is the importance of each word. If there is a word that is present in only one document and no other document has is, that word becomes more important in that document. And if there is a word which is present in all the documents, that word does not remain very important anymore. Okay, so here also it has stop words, it has n-grams, all the things are here. Right? You can see here. Let let me, it's a lot of digits, right? Import numpy as np. So that is where you use numpy, right? You're just rounding it up. Wait. The values will be in 2 decimals. Understood? So the importance will be in the scale of 0 and 1. So in first row, first line, what is the most important word? So in first, these 2 columns are very important, right? One, two, three, and 4. Hello and how. In the second line, 0.6 is the highest. In the third line, there are a few words which is coming in here, right? 0.4, 0.4. These are few important words. Let's now, if you change, because most of the words are present in all of them, isn't it? Or at least when I see this word is not present in all of them. Only this guy has it. That is the reason why if I mention these words multiple times in one document, like what was the word which was present 2 times? Good, huh? Good. See, line number 1. So I think that is the one. 0.6 you are seeing, right? See, good became more important here, right? Understood? Okay. So this is what is TF IDF factorizer. You are vectorizing the words. Each column means each thing, but the value corresponding is not the count of it, but rather importance of it. That is your TF IDF. Clear? That was all about text pre-processing. Sorry, one more. I forgot. Okay, 2 more actually. So the next is feature hashing.
Niranjan is asking one question.
TF-IDF is a mathematical function actually. Okay, so it just finds out, it uses the count of that particular word in that document divided by count of, a function of count of the word across all the documents, right? The full form is term frequency versus inverse document frequency. TF-IDF. Okay, this is what it means. This is how you use it. Okay. Now you have another option. Oh, sorry. So when you have a IDF transformer, right? It needs counter information. Like we have stored from count. Where is the data? D. D was our count information, right? See, this was D data, right? Okay, it has nothing but the counter information. The TF-IDF transformer actually takes counter data. D was the data, right? So this fit.
What is the purpose of using it?
Okay, so you can see here. See this. So there are two techniques. You understood the usage of it. This guy takes count information. Okay, this guy D guy actually. I think. Oh, fine. D was this data. Understood, right? See, this is your D data. This is your D. Ngram. Wait. Let's change this guy. TF, IDF. So here it figured out this value based on the importance of that column. You can see here this first guy had only one column here, right? So it is absolute one. Only one word was used earlier, right? It is absolute one. Next guy, this is kind of sounded very important word, isn't it? The first one. Okay, what was the first one? Good, right? Yeah. First was good. Right? So TF-IDF, what is the difference between TF-IDF vectorizer and TF-IDF transformer? TF-IDF transformer takes count information, and from that count information, it finds out what is the importance. Right? So you will pass, after applying count vectorizer only, you will pass it to TF-IDF transformer. Understood, right? Yeah. So this is TF-IDF vectorizer is these two steps in one line. Clear, right? Count vectorizer and these two steps in one line, and whereas this guy is TF-IDF vectorizer is in one shot you are doing it. That's the only difference. Clear? Okay. So we'll solve problems using this shortly. That will clear if not. Okay, now let's go to the second pass. So now remember you can have lot of possibilities of all these things, right? So what you can do, you have from sklearn dot feature extraction dot, you have something known as feature hasher. This is if your number of columns is 1 lakh, you cannot handle, I mean you can of course, but it's too much. What you can do is feature hasher is equal to feature hasher pass 10. 10 is the maximum number of columns, that maybe 5. Okay, fh dot df dot text. That's right. The number of columns that you want to deal with is fh dot transform df dot text. feature hasher. Okay, using feature hasher, you basically reduce the number of like 1,000 words. You'll mention here 5, so you'll get 5 columns only. It's limited by this utility. Just correcting the sentence. Yeah, so you actually don't have a fit function. I think so. Using the wrong name. Sorry, it is hashing vectorizer. Why did I use feature hash? Hashing vectorizer. Okay, that's what it is. So here you see, sorry for the wrong word. I was looking for hashing vectorizer actually. Okay, it is hashing vectorizer and give number of features 5. No matter of how many size the text you give, will actually end up with 5 columns only. Understood? So 10,000 words to 1 lakh words, it will be very much limited by that. So this is very useful if the number of words that you're dealing with is very large. You don't want to get into an unforeseen situation where you have 1 lakh columns, not possible, right? You will make it 10,000. Understood, right? This is your hashing vectorizer.
So how it will select the important words?
So it will actually combine multiple words into one column, different words into one column, and it will use derivative of all those things. This is how it works. It's hashing vectorizer. Is it clear? Okay. So, oh yeah, I was not searching. Not text. Hashing vectorizer. Fh dot fit df dot text. Fh dot transform. You can see 3 rows. And features. Number of features is 5 now. Understood, right? This is the same way, I mean, you are controlling the number of features. Okay. So yeah, that was pretty much around texts, right? Let me show a few things, a couple of things around image. How do you deal with images and all that? Right? Image from SK image, you have to install. You can either install sklearn package image library, or you can use this guy. Okay. So from skimage.io import im read, right? Using this package, Okay, this is SK image library. It has everything you can do, everything you want to do with images. Might take some time to load it. So IM read, you pass any image path here. It is leading that image. Okay, if you do img dot shape, it will give you image dimension 478 cross 850 cross 3. Why is it 3? RGB. Each pixel, yeah, each pixel is represented by this 3. Understood, right? RGB. This is how the image is. You want to see this image here? Okay, so you can use either not. You have one more library, but I would prefer it this way. You use visualization library to show it from matplotlib. Plot. Import matplotlib. SPLT percentage. Matplotlib in main. ELT.im show img. Alright, you know this gentleman?
Yes.
Okay. Okay, you have CMap. See, there is a scam here also. So okay. So yeah, I mean there are libraries using which you can. So I was trying to do it directly. Yeah, no, it won't happen actually. So the RGB information is there. Okay, so there are libraries using which you can convert this RGB to gray and all that. But basically, what? Yeah, I don't have like this. Okay, but what is the time? It's all pixel value here. Understood, right? Okay, just you can play around also. You can, if you want to convert some pixel values as black and white, you just mark those values as 0. Understood? Like img You got it right? I made it all 0. So that's what I'm trying to say here is, I can play around with image anything. We can use a lot of, SK image library has a lot of machine learning. I mean, all those image cropping, all those things. If you want, you can do that. I'm stopping this image stopping now here.
100
Huh? 100 rows, you are making it 0. That is why 0 to 100 rows all black.
You can give also different color. RGB.
Any color. 0 means black. Some others. See? So play around with that.
So just to get that you have plotted in Matplotlib. Coordinate.
Right. So that effortless is. Okay, cool. This was image. Oh, I forgot recording this one. Not recording. Also, meeting might end, so I'll resend the meeting again. Today I couldn't use the forward. Rather, I couldn't use the office account. Image processing. Okay, cool. So we have learned linear regressions, all the regularization techniques, right? Ridge, lasso, elastic net, right? Polynomial, multivariate. Yeah, I'll send all of the recordings.
One doubt. What is Unicode escape error? Actually, when I was loading the picture, I was getting
What?
Unicode escape error. It was not able to read 2 and 3rd byte. So I used the double slash. It was able to read it. I just searched on Google. So I used instead of single slash, I used double slash.
Oh, they're path issues actually.
Yeah.
Path issues. So either you can put R before it as a path.
Okay.
So
R comma
R before the entire path expression, put R before that. So that it treats as a raw string. Okay, so yeah, that's connected here. Just here. Okay, so yeah, so let's move to logistic regression now. Logistic regression नहीं हुआ था ना? हो गया था क्या? अच्छा, उसके बाद? Circle thing also done. I'm not doing. I haven't done this again, right? अच्छा ठीक है. कोर्स खत्म नहीं हुआ. ठीक है. So ठीक है. If you have any doubts, let me know. So logistic regression we have done linear regression, we have done some sort of pre-processing. Okay, now let's move to outliers. Some outlier understanding. What is outlier and all? That also is done.
outlier.
Oh,
Last class.
completely forgot.
Last
Class. Basic introduction. Right. That's all was intended. Now we'll do more things in outlier. Okay, fine. Then I'll start with the next algorithm, naive Bayes series. Okay, so you have revised probability. I think that I told you guys, right? Revised probability and all that. Okay.
पढ़ के आ जाएंगे.
हाँ?
Actually stop कर देते हैं. कुछ पढ़ के आ जाएंगे.
अच्छा. Okay, ठीक है. हाँ?
Probability.
हाँ, read little bit about probability. ठीक है. So tomorrow we'll discuss about naive Bayes. Okay, try out all these stuffs. ठीक है. The meeting is about to end. Then let me end the session here.
Yeah, it's okay.
Okay, yeah, these things are little like unless you do it, it's actually easy. Once you do it, that's all the thing is.
Naive Bayes is only used for what is the significance of
classification.
Actually, किसी ने पूछा उस सेशन में naive Bayes से मैं weather prediction कर सकता हूँ क्या?
जवाब हाँ, सनी होगा या फिर नहीं होगा या फिर क्या क्या होगा.
कर सकते हैं.
Linear plus logistic.
कितना बारिश होगा, that is linear regression. That is a regression problem basically. हाँ, क्या बारिश होगा नहीं होगा, that is a class thing, right?
Probability में